I'm CK. Tonight we're going to build something from Frequency Central. We're going to build their System X envelope. Their webpage asserts that it is their bestseller and that people love it. So we'll take a look at it, we'll put it together and see if we love it too. You can always use more envelopes. Hope you enjoy the video. Let's see what's in the box. It's packed by Frequency Central out of Coventry in the UK. Frequency Central full DIY kit, System X envelope. Here we go. Nice paper packaging, which I love, because I can recycle this. So we've got one, we've got a sticker. I know I have a Frequency Central sticker. I don't know if I have this one. Yeah, I do have this one. Frequency Central is my go-to power supply when I build up a new rack, so I have quite a few Frequency Central things. We have this bag, and we have this bag, and we have a strip of 90-degree pin headers. Well, that's interesting. And a eurorack power supply. First we'll get this box ready for the recycling bin. Now we'll look at the parts. This feels like the front panel and circuit board. And there's the front panel. Let's take a look at it real quickly. It's, since they are from Coventry in the UK, this is aluminium. Attack, decay, sustain, release. Pretty much straightforward. Gate range, normal and inverted. So looks pretty much standard for an envelope generator. Look at the board. Oh, there are two, count them, two circuit boards. Oh, that's why. Okay. I was wondering, because this is a pretty narrow module for doing something like an envelope, because an envelope is, as you know, more complex than, say, a multi, which just uses an op amp and can fit into something like this pretty simply. But looks like what we're going to do is we're going to take the 90-degree pin header and put it, say, on this board like so, and that will feed into that. So it'll be front panel with the logic board going at a 90-degree angle to it. So it saves horizontal space. Obviously you have to have the depth to be able to handle that deep of a module. I don't have a problem with that, but you may have built up a case that doesn't have that much depth. So let's look at the boards themselves. So it's revision 2020, so I'm assuming that means revision 2020. The components have their values listed on the board, including the potentiometers, which is nice. Plating is through hole, which is also very good. And here's the logic board. PCB by Johnston Dunn, designed by Rick Holt. Snappier than an alligator jacuzzi. Because an alligator jacuzzi would be pretty snappy, wouldn't it? And again, all the components are listed by value. So that will make it, that means we don't need a build guide if we don't care to use one. We could just slap it together without that. I will see if they have a build guide and use it if possible, because obviously part of the point of my doing these is for videos is for folks who are less experienced, and I assume that they are going to be going through the build guide step by step, because that's the way you learn best. This feels like hardware. It's like Christmas when you get a new kit. Okay. We've got pots, the standard pots you'll find in lots of eurorack units. Power connector, keyed power connector, not bare, which is good. And then some really kind of, oh, this is interesting. These knobs are almost good. They don't have a brass insert. They're just plastic to grip there, and that's not even very snug, which is not perfect. But they do have a brass set screw, which will lock things down. Now, of course, you got to be very careful when you're using a brass set screw through some plastic so you don't strip it. We'll talk about that later on. 3 jacks and 1 switch. So that's the mechanical bits for the I/O board. Now this is going to contain all our electronic parts. So I'm shuffling things around here. We'll put that in our rectangular bin. And you have to check really closely on these bags, because things like diodes can be very tiny and very light and can get lost in bags like these. Let's see what we got. Bunch of transistors, some probably voltage regulators. Looks that way. Some electrolytic caps, not very hefty, and I think they're only 25 volts. Oh no, these are 50 volts. Huh, good. An IC socket with a couple of legs already bent. Another IC socket with no legs bent. Then 2 ICs, I believe these are the little amplifiers. I'm going to look them up real quick. They're TL072s, and I think this is a 7.3. No, that's 7.1. Let me get the absolute right nomenclature for y'all. Yeah. As I said, they're just little op amps. Very handy. They're duals. Now this is nice. Here are all the resistors, and as you hopefully can see as I untangle them, someone has kindly enough written all the values on the little piece of paper that goes with them. Very good for someone who's not familiar with resistor color codes. Here are our assembly of diodes and a couple of LEDs. Actually, I think just one LED, unless I didn't see something. Yep. So not a lot of components. Looks like a good evening kit for someone. And it's time to get the soldering iron warmed up and take a stab at this. I'm also going to bring up the build guide on my iPad if they have one. They do have a build guide online. It's short and to the point because, as you can see, it's not a very complicated kit. The important part is they have some good pictures of the boards all put together, which is very confidence inspiring for folks, so I appreciate that quite a bit. Now, we're going to start with resistor and diode time. And if you've watched my videos, you know diode time is pretty, resistor and diode time, I speed up the playback because there's not a whole lot interesting to talk about when I'm installing resistors and diodes. So I'll be playing some of my compositions as background while you listen and watch 20 times speed of me putting resistors and diodes on the board. While I'm working, I will be listening to WQXR FM out of New York City, classical music station that I've been listening to my whole life. I now listen to it out here in California on the WQXR app that you can get from your appropriate app store. I find them to be the best classical music station I have ever found, and I've listened to a lot. So tonight we're going to start off with Alexander Glazunov, his Concerto in A minor for violin. WKXR has been on a Russian composer kick this week, which I think is pretty much A-OK. So enjoy watching resistor time whiz by. So resistor and diode time for the System X envelope is now over. As you can see, it's pretty straightforward. The only two challenges. One is the diode solder point spacing is the same as the resistors, and the diodes, as you can see, are an order of magnitude smaller than the resistors, so it's a little fiddly to get your bends right to make them drop straight in. The other thing is, I had done the 322K resistors, and then I reached into my pile of resistors to do, and there were 3 more 22K resistors. This is an extra stack of them, so it'll go in my extra parts bin, because there's no other place to put resistors. So that's it for diode and resistor time. I'm going to stop for this evening because I was out of town most of the day, and the cats did not get their noon treats, and they're mad at me, so I have to go give them their evening treats now, or they will tear the house up. See ya tomorrow. Okay, so now we're going to put the transistors on when we've got 5 BK033 NPNs, and we've got 3 of the BK021 PNPs. And they're marked as N and P on the circuit board, so they don't have the actual part designation. I don't know if that's because, I mean, it's very likely because any NPN or PNP transistor will work at, or almost any, obviously, something decided with a lot higher forward voltage than we've got on this board wouldn't work. But I'll do the ends first. And as you can see, this is just a little hint. I don't try and fight the transistors or other components out electrolytic caps also come like this, out of 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Where's the 7th one go? Oh, there it is. Okay. I don't try and fight the transistors out of this tape, because that's frustration abounding. So I just cut the leads off at the edge of the tape. You don't need more leads than that. It works fine on everything except capacitors. Since capacitors have a long leg indicating polarity, indicating the positive side, you're cutting the legs off evenly, so you're missing that indicator. Of course, electrolytics also have the stripe side indicating negative, so you don't need both. Just if you do it, remember, if you do what I'm doing, remember that you gotta get your polarity from a different indication than the long leg. Let's see, what else? Now I'm going to go ahead and put the IC sockets on. Only 2 of them. And again, we'll dress up this little bent pin with needle nose to get all of them aligned. This one's tilted too. Both of them are. That's why these are generally packed in little pieces of foam, but that didn't happen this time. So I'm resting them on my finger from the back. Soldering one leg of each. Now I'm going to take a look, make sure it's all flat. Yep. Now the electrolytics. Wait, I'm not going to do the electrolytics right now. Lost my head. I'm going to do the power connector now. And it's got a mark for where the notch is, and I'll set it like that. But I'm also going to go grab the power cable and just verify that that's the right red stripe side. And it is, so I can go ahead and solder it. And same drill. Solder one pin, check alignment, check perpendicularity and flatness to the board. And that's not flat, so I'm going to put my finger against it and heat that leg up again. And I actually got 2 legs soldered there. Ow. And of course burning myself like I always do, because the pins of course transmit heat. There we go. All flat. Now we'll do the electrolytics. Now I'm looking here and I don't see space for any other electrolytics. I've got 2 more left over. Do they go on this board? Oh, they do. They go on this board. This is the 1 microfarad that goes here, and there's the LED. Okay. But I don't see the. It's also, it wants a 10 microfarad here, but I do not have any 10 micro. Oh, there it is. It's identical to the other one. Wow, that's interesting. I would have. It's not identical. It's actually slightly smaller, but I didn't notice it. That would have been bad. Probably not catastrophic, but it would have been. It would have behaved oddly. Now we're going to put the pin head, the 90-degree pin header on, and it goes on according to the picture, like so. So we will cut at this point. There we go. And I've got some 90-degree pin header left over to go in my spare parts from kits box. Okay, now we've got 20-some pins to solder, so we'll go into fast replay. Double checking to make sure all the solder joints look good, and they do. And I'm not going to clip these pins off because I'm too lazy, and it won't benefit me at all to clip those pins off. Now I'm going to put the two ICs on the board, and then we can move on to the pots and knobs board. I mean, pots and jacks board. 701 goes here, 702 goes here. And that is silk screened on the board, and you can see the silk screen through the center of the socket. Okay, this board is done. That's the way it looks when it's done. Obviously you may want to neaten up how your transistors stand. I don't care personally. I am double checking on these because the solder pads are very close together, and as the solder wicks through the board, I want to make sure it didn't spread. So that goes aside. Now we've got the pot board, the pot and whatever board, and these are not all the same pots. So you gotta look at that. There's 500K, 100K, and 1 megohm pots here. The other thing I'm gonna do is take the nuts and washers off. Pins are a little cattywampus, and I'm trying to force them, which is dumb, so I'll just use the needle nose again to straighten them out. That is the smart way to do it. Now the jacks, and the author of the build guide says use some resistor legs for the ground pin, but these are newer style jacks that have the integral pin, which is nice. Now we test fit the panel to make sure before we solder that everything is aligned and spaced well and all other kinds of goodness. And it's not because, and I'm going to check this with my ruler. So that's sitting at about 14 millimeters. And down here, it's less than that, and it's because I did not. There are two pots that have alignment tabs on them, here and here, and they're keeping this end up a little bit. So I'm going to nip them off. Let me go get my nipping pliers. For nipping larger pieces of metal like this, I don't use my regular bench diagonal cutters. I have a set of carbide tip cutters that are, yes, they are more expensive, but they're going to be able to cut pretty much anything without damaging the jaws at all. And I prefer to buy one pair of these for that purpose, so I'm not, over the years, buying 2 or 3 pairs of these because I've messed up the jaws cutting thicker or stronger metal. So you do pay a little bit more up front, but then the economy long term works out for you. And the carbide jawed cutters, carbide steel jawed cutters, also cut really well and really you're never going to fight with them when you're cutting through something. What are we doing here? You went in before just fine. Why are you fighting with me now? There we go. There we go. And you are correct. I did not put the LED through yet. That's because I am not done. I am not going to be leaving this on. Actually, may as well just put it on there and have it dangle. Because actually I hadn't thought about this. I haven't thought about how this connects. So I am going to have to take it back off, the panel back off, to solder the daughter board or the logic board on. So I am not going to be soldering the LED right yet because I'm going to take the panel off one more time. And I don't want to have to mess with that. So I'm going to do solder one leg of pot down here. And screw that panel nut down pretty firmly. Now I'm going to do one pin of the jack down here. And put a panel nut on that. I'm going to check my heights again. And they're just about perfect. Now I can do all the rest of them. Okay, so that's all the components except for the LED, which I'm going to leave for last. Double checking my solder connections. All look good. Now I'm going to take the panel back off Now, one thing the guide does not have is it does not have a picture of this put together. So someone might think, I mean, you could theoretically put it together like that, which would obviously be wrong, but it's a good idea just to give people pictures, even if you think it's obvious. Give them a picture. Now this, okay, I'm not going to be able to get at that those LED leads comfortably. I can, but I'm going to go ahead and solder them on before I solder the daughter board on. Changed my mind. I will just be careful not to bang it around in the process. So again, I'm just going to put one of the jack panel nuts on to hold the panel in place while I do this. So I've snugged it up so it's through the hole. I'll probably get my head in the shot on this one. Okay, let me trim those leads off because they're long enough that they interfere with the components on the other board. Now I can take this panel nut back off. Fortunately, even if I do jostle the LED out of alignment, there's plenty of space in here to get a pair of pliers in. Here's my pliers. I mean pliers. To get a pair of tweezers in there and move it around so it aligns again, so I'm not too worried about it. Now, the final bit again. And I'm confusing myself now. This one I do want to get as perpendicular as I can. So I'm going to do a leg in the middle. So now, let me double check. Make sure nothing's bridged, to make sure they're all soldered. Now I can put the panel on for real. And the LED went through the slot very easily. And again, I'm not using any washers on these pots because I don't care. You will probably want to put washers on there. Same as in your shop, you will probably want to have a little ventilation instead of leaning over your soldering spot and getting rosin and lead fumes up your nose. I, again, don't care. If I'm sitting here smoking a pipe while I'm soldering, it doesn't make much. Never mind to me to inhale a little rosin fumes. And when we talk about ventilation, you don't need to get a fancy soldering station evacuation unit. You can if you want, obviously that would be the ideal, but you don't need it. A simple small desk fan, one of those 2 or 3 inch diameter desk fans, just blowing across the work surface will provide you with not perfect but substantial ventilation to blow away all the fumes you're picking up. And I do for people who actually care about what they're breathing, not like me. I do recommend that. I tighten these panel nuts with these flathead pliers. You don't find them in your regular tools section. You can find these actually in jewelry making catalog. Jewelrysupply.com, for example, carries some interesting pliers that you might not normally think to use. You can also go high-end Exolite, Schmitz, and so on have these too. And Weir, or whatever they're called, the other Weller sub-brand, I forget the name of it. But these are, I use these so little that inexpensive ones are fine. Okay, soldering iron goes off. First I got to clean the soldering tip up. Soldering iron goes off. Power cable goes in. And she is done, except for, nope, not done, the knobs. And here is my greatest personal challenge. Getting the index marks on all the knobs to be kind of close to each other. I'm terrible at this. On a unit like this, it's not too bad, but when I tear down and then rebuild, say a guitar amp, say a Princeton Verb with all the little witch's hat knobs, I never get the stripes lined up with each other. I'm sure there's a way to do it. It isn't just eyeballing them, but I have not found it. Oops, see there, I'm already going to mess that up. I've already messed it up. Okay, so that's the front. Side. Other side. Top. And bottom. All the knobs move smoothly. Actually, these two don't. They're a little farther down on the shaft than I would like, so they're rubbing against the... Take it up just a hair. That's better. Loosen it. Take it up just a hair. That's good. Now they all rotate freely. Get a jack. Jacks all work fine. And the switch works. Time to put it in the rack and give her a spin. Now we'll demo it. Now, in actuality, I shot the demo last night, but I didn't do any oscilloscope traces, so I wanted to reshoot it this morning and do the oscilloscope traces, and this time I'm going to do picture-in-picture for the oscilloscope, hopefully, if I don't mess that up. So we'll get some good oscilloscope traces. A couple of things I want to point out. First, here's the Bafaco ADSR, and as you can see, it's about 2.5 times wider than the System X envelope generator, but obviously the Befaco does more. It's got the ins and outs and the sliders and so on. But if all you need is an envelope generator, you can get two of those in the same place. They're very tiny. The other thing I'm doing here is the output from the envelope generator, I'm taking it in to this Patching Panda copycat. So the voltage is going in here, and I've got the voltage coming out to the Danny Sound VCA, but I've also got it coming out to my oscilloscope input. So I've got a good, I'm not just splitting it, the voltage is actually the same because the copycat maintains pretty precise. It's not perfect, but it's pretty precise. And I'll be using the Adeco VCO and the Befaco Midi Thing to provide input. I'm also going to use input from the Division 6 sequencer. So let me reposition the camera to be close up on here, and I'll turn on the other camera and we'll get picture in picture, hopefully. Okay, we're all set up, I think. I've got everything on the envelope generator down at the lowest, and I've got the multiplier set high, set to not changing. This allows the input voltage to be changed, the output voltage to be changed to create, actually not the... So let's try it with everything down and hear what it sounds like. And you'll notice on the oscilloscope I'm not getting anything because I don't have the time base set for something this short. So let's turn up the attack a little bit. Give it a little decay time. Give it a little sustain, and I'll hold the key down. And then we'll add in some release. I'm going to turn up the sustain all the way. And you can see on the scope, it's holding the voltage high. I'm going to turn that back down, and I'm going to double now. See how the attack segment is now stretched out? I'm going to lower the tone of the keyboard. So I'm going to take the attack way down. And take the release all the way up. Hands are not on the keyboard. So it goes a long way with that doubled, or whatever the multiplier is. I'm going to take it out now. And take the release down to something normal. Okay, now I'm going to put it in the sequencer. With a naive little sequence, I'm going to start it slow. I'm wrong, that was fast, wasn't it? So there's a moderate speed sequence. I'm going to speed it up very fast. So that's what we've got. As you can see, when the sequence is set to be very fast, it is very responsive. It didn't drop any notes. It all sounded good. It's a straightforward unit to use. Of course, there's not much else other than the doubling of the segment and the inverting the envelope, which I didn't show you. I'm not going to bother with that. Pretty straightforward build, good quality parts. I think this is a winner. I recommend it very much. Thanks for watching the video.